Alright, I'm going to start by telling you a story about two kinds of materials. So we have one kind of material that is a conductor, another kind that is an insulator. Now, what makes these materials special is very simple. In the insulator, we have electrons, and the electrons are trapped. They can't move around very easily, and so they just kind of stay put. In a conductor, conductors are materials where the electrons, they just dance around all over the place. Okay, going from one place to the next, just kind of a huge party over here. Okay, and so conductors are materials that, because electrons can move freely, conduct electricity. Okay, they'll generally be able to conduct heat very well too. Okay, whereas an insulator, it's not very good at conducting electricity, and so you would use it if you're trying to prevent the flow of electricity. Okay, so these electrons, they like to dance around, and if you were able to somehow kind of give them a little push from this side, so let's say, we'll get more into this later, but if you have two charges that are the same, they repel each other. They push away from each other. So if we were to put a negative charge right here, it would kind of give a little push to these guys. And so they would still just kind of be dancing around, but as they danced around, they'd kind of slowly be shifting this way. Okay? And so when we give these electrons a push and they start to move this way, we call that a current. Okay? So by giving them this push here, okay, and maybe you put a positive charge here to pull them that way, we can create a current because the electrons are going to start generally moving that way. They're just going to be kind of meandering their way through, okay, but they're going to kind of generally move toward that direction, okay? And when you have an electric circuit, what's going on is the electrons are moving, okay? That's what current is, okay? So we're going to learn a couple of terms here. The first one is current, okay, and current is the flow of electrons, okay, and when there's current, then things happen. Okay, so in addition to current, we can talk about this thing, this push that we're giving it, and how strong that push is. Okay, the name that we give for that push and the measurement of how much push we're giving is voltage. Okay, when we apply a voltage, another word for this is a potential difference, but when we apply a voltage across some region of a conductor, then it's going to cause electrons to flow. It's going to create a current. Okay, now some materials are easier for electrons to move through than others, okay, and those other materials, or maybe the electrons just don't move quite as fast, okay, maybe they're still moving, just not as fast. And so whenever we have a material like this, where electrons move more slowly, we say that it has a higher resistance, okay? And when we talk about electricity and electric circuits, these are the three really important concepts that we need to understand. All three of these things are very closely related together. How fast the electrons move, how difficult it is for them to move through something, and how hard we're pushing them. Okay? Alright, so before we continue, current is measured in amps, okay, which is abbreviated with A. Amps itself is short for amperes, okay, but we just use the symbol A, okay, and the variable we use for current is I. Okay, voltage is measured in volts, and the symbol we use for volts is V, or I guess the unit is V, and then the symbol we use is V as well. And then resistance is measured in ohms, O-H-M-S, and the symbol we use for ohms, or rather the unit again for ohms, omega, okay, the Greek symbol. And the unit we use for resistance is R. Okay, so these are the three, sorry, not the unit, the quantity or the variable we use is R. So these are the three quantities we'll be comparing as we talk about current, voltage, and resistance. Okay?